So in this video I'm going to tell you about a couple of simple ways of describing a sample, which are the range and the median of the sample. So the range is simply the range of values that our sample takes up, that the measurements in our sample take up on a number line. So that's equal to the largest measurement subtracted by the smallest measurement. It's fairly straightforward, I think. That's the range, and then the median is we can write that as x with a squiggle over the top like that, and that we can think of that as the middle number in the sample. And again, I'm going to show you with an example. So I'm going to give you a data set to work with. So let's imagine we've measured some things, and we've got 20, 26, 5, 17, 1, 35, 28, 5 and 10. So the first thing we have to do is rank these in order. Rank your measurements. So we're going from the lowest number to the highest number. So our smallest number here is 1, then 5, and then hold on, I've copied this down slightly wrong from my other notes. What have I done? Yes, this one I want to say, say this is 21. Sorry, it has to be the same as my other notes or I get confused. So say 1, 5, 10, 17, 20, 21, 26, 28, 35. Okay, so I've just ordered these from the smallest number to the largest number, and n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because we have 9 measurements. So now let's work out first of all the range. So that's equal to the largest measurement minus the smallest measurement, so that's 35 minus 1, or 34. Or we could also write that as, with square brackets like that, 1 to 35. And then we're looking for our median. So that's the number where we've got as many numbers smaller than it as there are numbers bigger than it. So in this case, we want the number where there are 1, 2, 3, 4 values smaller and 1, 2, 3, 4 values bigger. So that is 20. Okay, so 1, 2, it's the fifth value out of 9. So we need as many values smaller as there are values bigger. So that's 20. And just for fun, we could work out the mean of our sample, the arithmetic mean, and that would be, if we add up, so that's sum of x over n, which is 163 divided by 9, or 18.1. So here our mean and our median are quite similar to each other. Okay, I think that's it for that example, but now I'm going to give you a second one to prove a point, that the mean and the median do not have to be close together as in this sample. So how about if we've got another sample and these are ranked already in order. So how about if we've got 1, 5, 10, 17, 20, 37, 54, 102, 250. Okay, so now, so our n is still equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 measurements. The range here, though, is much larger, so that's 250 minus 1, or 249. The median, again, it's got to have 4 numbers smaller, 4 numbers larger, so that's 1, 2, 3, 4, 1, 2, 3, 4. So the median is the same for these two samples. And if we work out the mean, that is equal to 496 over 9, or 55.1. So here we've got the same median, but the range and the mean are quite different between these two samples. Okay, so what do we do if we have an even number of samples? So here we've got both these samples have an odd number of measurements in them, and so it's quite easy to work out how many are above and below. So I'm going to show you how to deal with a sample with an even number of measurements, a sample or a population. So let's imagine we've got 1, 5, 10, 17, 20, 25, 37, 54, 102, 250. So I've added an extra value. I've taken an extra measurement. So here n equals 10. So here you need to look at the two. So here we've got even number of measurements. Take the middle one. Or if you've got an odd number of measurements, average the two middle ones. So in this case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our middle ones will be, so here again will be 20 and 25. So we've got 4 smaller, small, bigger, 4 smaller, 4 bigger. And so we need to average these two, which is 22.5. So in this case, the range is the same as before, 249. The median is slightly different, and I've shown you how I worked that out, so that's 22.5. And the mean is going to be quite similar to before, so that's 521 divided by 10, because n equals 10 this time, and that is 52.1. Okay, so that's two more interesting ways of describing a sample or a population of continuous measurements. So that's the range and the median.